This is Jason. He is a developer who wants to use zero-knowledge proofs to create a private ecosystem. The problem is, directly accessing libraries that turn ZK circuits into proofs is proving to be a bottleneck in the process. He wants a better solution but doesn't know where to look. Don't worry, Jason. Because for developers like you, Aleo has developed a dynamic circuit compiler language called Leo that minimizes the cryptographic knowledge required to quickly create a private and decentralized ecosystem. ZKP is made by a proof system and something called a ZK circuit, which is supposed to be built by the developer. This is the key stage where developers like Jason left out wanting for a better and faster solution. This is where Aleo comes in. Aleo is now building a circuit compiler Leo that turns high-level app ideas into ZK circuits, saving time and effort and eliminating human error. Some of the key features of Leo are statistically typed programming language, designed to be reminiscent of JavaScript and TypeScript. Short learning curve, intuitive to use. Several world's first features such as a testing framework, package registry, import resolver, remote compiler, and theorem generator for general-purpose, zero-knowledge applications. This means Jason can now quickly write a Leo program without worrying about what is happening in the background. But what is exactly happening in the background? Well, Leo takes Jason's code, constructs the proof circuit that represents the computation he wants to run, populates the input wires with the values he wants, runs the circuit, generates proving verifying keys, and then combines all the relevant data into its ZKP. Leo outputs proof when a computation runs correctly. And how can Leo help with scaling? If you were to run the above circuit on some array and present the output array alongside the proof, any observers would be able to confirm that the array was actually sorted by checking the proof rather than the array. Leo does more than just make the circuit for you and generate the proof from it. It is packed with functionality that helps reduce developer times as much as possible. The testing framework, package registry, and import resolver all work together to save developers a lot of time ensuring that external functionality is imported easily and that the code actually does what it was expected to do. Now Jason can confidently scale up, knowing that even with data structures that have millions of items and more complex computations, checking the proof, which is always the same size, starts to convey a lot more value. Jason is happy that he found Leo to make valuable applications himself without having to mess around libraries. So if you are building an ecosystem whose core aim is to allow the development of scalable applications that are private, one of the best ways to nurture the growth is to remove as much friction in application development as possible. This is what Leo is helping to achieve.